we're going to finish lesson 1.5 with a look at how can we use percentages to do scaling. So back with the film of Titanic, there was a model of the stern, which I believe is the front part of the ship, or is it the back part? I don't know. Was created at 12.5% of the actual size. Now, if we just went back to our thinking of lesson 1.1, if we wanted the scale part, we do 0.125 times the actual size is going to equal the scale size, right? That's our just our basic understanding of percentages. We take the percent of the amount of the total, and we get the amount. So using that knowledge here, we've got a section of rail in the stern of the real Titanic. Notice this is the actual size, was 20 feet long. How long would the corresponding section on the model be used for the movie? Well, we would just take 12.5% of 24 feet, and that gets us the amount. All right, let's jump to decimals real quick. 0.125, try again, 0.125 times 24, and we get, surprise, 3 feet. Now, we need to be a little bit careful in our thinking here. The measurements of these feet are the same, but this is the actual size, and this is the scale size. So just understand where we're at. All right, so if an I-beam on the model was 30 feet of deck space, notice this is the small size, how big is the corresponding on the actual ship? Well, if we use this as our pattern, we do 0.25 times the real, so I'll put in here actual, equals the scale size. Well, the scale size is 30 feet. You may recall this problem. Simply divide both sides by the decimal equivalent of the percentage, and we get the actual size. Again, let's jump to Desmos. 30 divided by 0.125, and we get 240 feet. So notice we're doing the exact same thing. If we want to scale from large to small, we multiply by the fraction. If we want to scale from small to large, we divide by the decimal equivalent of the percentage. He asked us to do something slightly different. So let's turn this into a problem we already know how to solve. Given that the model size was 12.5% of the real ship size, write a reduced fraction that describes the scale in fractional form. Well, we can do 12.5 divided by 100. That's our scale. So this would be small to large units, and these are unitless units. And let me show you, I don't know if we've seen this yet, how to convert this to a simplified fraction in Desmos. We get 0.125, we already knew that, but if we hit this fraction button, notice that was on the left side, we can convert between decimals and fractions here. We get 1 to 8, meaning 1 foot of scale equals 8 foot of actual. Notice we could have also used our equivalency statement that we had up here. We had 24 feet of actual to 3 feet of scale. If we do that division, you get the same thing, 1 over 8. So there's your connection. Now, let's just jump back real quick to that original problem where we had 1 to 13. We can convert that to a percentage. Just divide 1 by 13 and you get the decimal equivalent of a percentage. 1 divided by 13, that's 0.0769, blah, blah, blah. Here's the problem. We would have to round that, and then our accuracy is going to be a little bit off. I'm going to do 0.777, rounding 2 decimals. So that would mean the scale of 1 to 13, an approximation of it is at 7.7% of the actual size. Okay, that's the end of 1.5. Let me just highlight, here's a list of convenient conversion factors that are often useful. And you may be thinking, hey, can't I just ask Siri to do this conversion for you? And the answer is yes, you can. But I think sometimes it's nice to know what is the calculation that's going on behind the scenes. Some programmer had to program Siri to do these correct calculations, and you now know how they programmed it, or at least the mathematics that they had to type in, maybe not the actual code.